All right, so this is lesson 5, day 3, thermal energy in a system, and this is the phases of matter gizmo. So I'm going to show you the gizmo here, as you can see on the right side of the screen. I have it split screen with the actual slide deck that you'll be filling out. So we'll go through each slide along with what the gizmo is going to show to help you answer all the questions in the slide deck. You can find this gizmo if you log in, and it is the phases of matter gizmo. It is assigned to your class. This video is designed to help guide you through the slide deck to do the assignment, and you can pause at any time to answer the questions in each slide. So here we go. We'll get started. Okay, so we drew two models. One model showed how water can escape the liquid part of a system, our cup, and go into the air as gas and become water vapor. If there is no lid, we found that mass decreases in that system because some of the water particles left the system, the cup, out of the space where the lid would be. Then we found with our condensation lab that matter in the system can increase. Mass can increase because air around the cup, water vapor that's already around the cup in the air, can stick to the sides of the cup and become water, and we call that condensation. So this phases of matter gizmo is going to give us a little bit more information about how particles, especially in water, we're going to focus on water, but how particles in solids, liquids, and gases can change their state, go from liquid to gas, gas back to liquid, and even melting, which is a solid to a liquid, or freezing, which is liquid back to solid. And we did find out in our whiteboard modeling, we came to an agreement that temperature has something to do with these changes, either a gain of energy or a loss of energy. So this gizmo will show us what happens when we add heat to a system, or if we remove heat from the system, what's going to happen. All right, so here we go. All right, so our objectives is to understand that in normal conditions, water can exist in 3 different states. We're going to compare solids, liquids, and gases in terms of having a fixed shape or volume. And we're going to describe the phase changes that occur when heat is added to or removed from the water. We'll compare the structure, spacing, and motion of molecules in solids, and liquids, and gases. So in this third slide, you have 3 images here. And what phases do you think are shown in the 3 images below? So we have picture 1. What do you think that is? Is that a gas, a solid, or a liquid? How about number 2? We're talking about water. Could that be a solid, a liquid, or a gas? And then finally, number 3. So I'm going to show in the gizmo what's going to occur inside of the water with the particles, also a gas, and also a solid, and see if we can compare the pictures to what we see in our little system here. Okay, so I'm going to drag this magnifying glass, and here we see a picture of molecules just moving around. Sometimes they touch, they sometimes bounce off one another, sometimes they bounce off the container. We also see them moving kind of at a medium speed. They're not really going slowly, but they're not really going very rapidly either. Now I'm going to add heat. And we're going to see what happens to these water molecules. So we can see that the temperature is rising. 100 degrees Celsius is boiling. And we notice that the system is filling up with water vapor. So as our water leaves the water area, so particles in the water are leaving, as we can see, to go up into the air. We're going to take a look at what these particles look like as a gas. All right, so they're very far and spaced apart, very random. All right, and so what picture do you think that matches? And again, this is a gas, water evaporating up into the system. Okay, now I'm going to slow down our temperature, or I should say lower our temperature. And that the gas, the amount of gas is decreasing. We see more particles in the area, so maybe particles are coming closer together. We're going to drop our magnifying glass. We can see water level rising again as gas is decreasing. So this is a closed system. So the same amount of particles, there aren't any more particles in the system and there aren't any less particles. It keeps the same amount of particles. So now we're going to take a look at the water. So there's the water again, and we can see the gas molecules dropping back into the water, and they are all water now. And our temperature is now decreasing as we are continuing to chill the system. All right, so now we see that this water is becoming ice. And take a look at what the molecules are doing. So what picture do you think that matches? 1, 2, or 3? Notice that these molecules take on a little bit of a pattern, kind of a hexagonal shape here. And they are closer together. They aren't moving very randomly. They're just kind of vibrating in place here. But they're still moving. They almost seem like they're attached. Okay, so in this slide, you have to identify 1 as either a solid, liquid, or a gas. Same with 2 and then 3. And then describe the spacing of the molecules for each of the phases of matter shown in the image. So are they far apart? Are they close together? Are they randomly spaced? Are they creating some kind of pattern in each of the areas of the solid, of the ice? So you will do that in number 1. So you could pause this video, finish up slide number 1, and then move on to slide number 2. Actually, this is slide 4, but the second thing that you have to do. All right, so here's the warm-up. It says, after the heat is applied, what happens when the temperature stops rising? So we're going to add heat again. We're going to create a melting situation. So this ice, we can see, is slowly trying to turn into some water. And now we are melting. We have ice turning into water. And we're going to watch that temperature rise. Now it's super hot, getting up there to boiling. All right. And the temperature stopped rising. So what happened? We move the magnifying glass. As soon as this temperature stopped rising, we noticed something here. So what's going on right here? What color is it? What color is this? This is liquid water, and at the boiling point, this liquid water did something. Why do you think the lid is lifting? So here we have a lid on our system. Why is the lid going up? Why is it lifting? Take a look at what the molecules are doing. What are the molecules doing? Are they lifting? So what's happening there? All right, we're going to remove energy. For number 3, what happens when energy is removed? What's happening to the lid? What's happening to the space right here? What's happening to the molecules? Magnifying glass around. See happening. What's happening to the lid? How would you describe our gas versus water? What's happening to the gas? What's happening to the water? What do we see happening with the molecules? Think about what process we have going on right now. Okay. We'll go on to number 5. Again, you can pause the video and answer questions 1, 2, or 3. 1, 2, and 3. We'll go on to slide number 5. All right, so here's our investigative question in the Gizmo. How does temperature affect the phase of water? So in the Gizmo, solid ice is gray, as we can see here, and liquid water is blue, and water vapor is light blue. We're going to heat, and then we're going to chill the water as needed to reach the temperatures below. And then we'll hold it steady. And you have to decide what phase the water is in at those temperatures. So I'm going to chill it and hold it steady. We'll do our best, my best, to go to negative 20. All right, here we go. Oh, there we go. I did it. Okay, so take a look at the particles. What did we decide this was back in slide 3? Is this a solid, a liquid, or a gas? Notice the color that we have down here as well. Okay, now we're going to heat it back up. We're going to get back up to 30 degrees Celsius, which is warmer than room temperature. This is melting, so at 0 degrees, we can see that ice starts to melt. Oh, oh. All right. I got to chill it back down to 30. All right, that's hard to do. Okay, good enough. So around 30 degrees Celsius, what phase of matter do we have? Notice that there are no particles up here. What color is it if you match it to the key? What phase of the water, what phase is the water at 105 degrees? So letter C. This is really hot. This is above boiling. So notice the water level is dropping and our water vapor is increasing. So we're just kind of switching out the phases. We're not really gaining or losing any matter in any of these phase changes. We're just kind of changing the phase that they become. Losing water. We are gaining water vapor. One 105. All right. Good enough. Okay. So now what phase are we in? Notice what color it matches for letter C. Okay. All right, slide number 6, the investigative question is the same. How does temperature affect the phase of water? We're going to hypothesize first. How does temperature affect the phase of water? Predict the phase of water at 6 different temperatures given below. List your predictions in the predicted phase row of the table. So you're going to first, before you do anything with the gizmo, we're going to predict what phase we think it is. Is it solid, S for solid, L for liquid, or G for gas? Then you're going to fill in the actual phase row shown in the gizmo. So what do we think at negative 10, what do we think it is? How about at 10 degrees Celsius? Or 50? Maybe 90 degrees Celsius. 110 and 120. So make your predictions. You can pause the video for that and then start it up again. All right, so let's look at the actual phase. I've got to get this down to negative 10. I'm going to hold my magnifying glass right there. Uh-oh. News report wanted to just pop up. There we go. Getting there. Hope you're all having a good day. I feel like I could tell a joke here if I could think of one. Why can't you trust atoms? because they make up everything. Be filling out these right here because we did kind of see, well, we're at 100, so maybe not, but you could do 90. We're coming up to 90. All right, so at 90, what is it? At 50, what is it? Now we're coming up to 10. What's the phase? And now we're going to chill it to negative 10. All right, and what is the actual phase at negative 10? All right. All right, now we're going to heat it back up because I think we need to see the 110 and the 120. What actual phase is that? Probably should have gone up, then down. That's okay. Melting. It's going to go quick now. All right, we can see our water level will probably be decreasing as we see at 100 degrees, water vapor increasing. Point of 110 and 120 degrees Celsius, we'll get our actual phase. All right, the water is almost done boiling. Everything turning into water vapor. Wonder why it's a little darker over here. Should we move this over here? Why is this darker over here? Interesting. Sides of the container, the molecules are this color. All right, there's the 120, so it's gas. I hope you saw what the 110 was. And there is 110. All right, what phase of matter is it there? All right, moving on to the next slide. So while testing our predictions, we may have noticed that there were specific temperatures at which the phase of the water always changed. At what temperature does water melt, going from a solid to a liquid? So we're going to take it all the way down. What temperature does water boil? That's going from a liquid to a gas. Note, boiling is a form of evaporation. It just occurs at a quicker pace because it's going to be at a higher temperature. We're going to add a lot of heat to get it to boil, but the process is still the same, where the water molecules lift up, leave water, and become water vapor. At what temperature does water condense? Change from a gas to a liquid. All right, so it looks like we might be condensing. Yep, we're condensing. So what temperature is that? This would be letter C. What temperature is condensing? What temperature is that? At what temperature does water freeze? We're just going to keep letting it go. All right. And what temperature does it freeze? We're going to see the word freezing down here, and then we'll pause it. Oh, all right. 0 degrees, right, for freezing. All right, let that heat, and then we'll do letter A and B. It's melting. So we saw that it melted at 0. You can rewind the video if you didn't see it. At what temperature does water boil? There it is, boiling. All right. All right, slide number 8. How are the phases of water different from one another? We're going to hypothesize one of the 3 phases holds its shape. The other 2 do not. So based on your experience, which phase has a fixed shape? Meaning it doesn't change even when you put it into different sized containers. The shape doesn't change. And B, which phases have a shape that can change? So whatever container you put it in, there are 2 phases where their shape can change. So think about maybe a bottle or a jar or a cup. And also think about maybe a balloon. How does a balloon change its shape? Slide 9. How are the phases of water different from one another? Water is made of small particles called molecules. So using the magnifying glass, let's see what the molecules of ice look like. Then we'll heat and observe the liquid and gas phases. Use the tools above. You're going to draw a sketch of the molecules in each phase below. So as we chill it, we're turning it back into ice. And what do the molecules look like? Okay. And then we'll heat it up again. And what does it look like as liquid? There they are as liquid. And then finally, how do they look as a gas? So this is a slide you may have to spend some time on. You're going to go up to the drawing tools area up here, and you're going to insert shapes. So you'll take the shape, and you want circles. So you're going to click on circles, and if we're going to draw particles, we're just going to click and drag, and there's your particle. And you probably should fill it in, so paint can, you can use blue, and there it is. Now, easy way to do this, so you don't have to keep drawing all the circles, is to just copy and paste. So 2 fingers in the middle, and you're going to copy. You'll just keep pasting until you get a bunch of particles. And then you're going to have to arrange them in ways that would match what a solid looks like, what a liquid looks like, and then what a gas looks like. And then slide number 10, how are the phases of water different from one another? So based on your sketches, why do solids have a fixed shape? So think about an actual solid. So think about your desk, your chair, the door, your, I don't know, pencil, anything that's a solid. Why do they have a fixed shape? Does it have something to do with how the particles are arranged? And why do liquids and gases not? Are liquids and gases attached to one another? Are solids attached to one another? So why would solids have a fixed shape while liquids and gases do not? All right, that is it. See you later. Hope this helps. Bye.